Hey everyone, good morning, good afternoon. This is going to be a bit of a solo cast. I am going to be sharing about the phi ratio and the vector equilibrium today. And since it is me coming to you solo, you might need to pause the recording when we're drawing because I'm going to go relatively fast because I don't have a pace to follow along with. So as you're drawing, um, keep that in mind. Go ahead and put me on pause, and it's just going to be a different kind of day today. Um, I want to say blessings to you, and I hope that you're doing well if you're watching this in future time. Um, I'll just say a moment, it's what is it? October. It's October. Is it the 21st today? Uh, we are in the middle of an eclipse window, and man, it is a powerful one. I could go into details and wax poetic about how this thing is so influential on the human psyche. Um, but I'm not sure the details of existential crisis are reasonable for this video. But it's been so intense. So it doesn't surprise me that I am flying solo in this recording. And, the collective, right? What does that even mean? This shared consciousness, how does that happen that we're all connected and that we can be experiencing astrological significance and have our lives really influenced by these larger forces. And a big answer to that question is through the geometry. It's this unifying principle. It's the element of the quantum field, right? It connects, um, I want to say, fluidly communicates, right, between all beings, right? Sentient beings, animals, humans, the planets, solar system. I'm actually gonna skip the grounding because I was grounding for a little while to prepare for this class, aka presentation. So the unified field, part of what got me into the geometry is that the new physics is talking about sacred geometry. Well, they don't say sacred geometry anymore. They really actually these days call it fundamental geometry or fundamental patterns to try and actually get away from that association of sacred or religiosity or anything that might turn anybody off with the languaging. So these fundamental principles of our reality are the building blocks, and that's part of why I'm so intrigued and fascinated by them, is because learning to draw them, connecting to them, connecting to the universality of them has really helped ground me in this dimension because I struggle to be here at times. It feels very dense, especially during solar and lunar eclipses. And um, I don't like personally feeling um, influenced by collective um, experiences, right? I just want to do my own thing. So to sometimes to realize the connectivity um, with humanity is it can be fabulous and it can also be challenging if if you feel like you're not really from this planet and you have galactic origins. It can look a little strange sometimes on this planet and this civilization. uh, but we could suggest that working with geometry can help you have some choice around separation or connectivity. Although really the thing is there's just no such thing as separation. So then we would look to spirituality and the higher vibes of understanding how to transcend the density of this dimension. Clearly, I am in some existential crisis and review and life review. So I'm going to get into the phi. This is really a review. We looked at this information in the first class. So I'm going to move through the remembering, and then we'll get into the drawing. And like I said, I'm really just going to be walking through it. I'm not going to be pausing for anyone's drawing. So the process will be with the drawing part, you will need to pause quite a bit. So let me see. Let me do my screen share. And then we're going to go into, nope, that's my email. Go into the file. And all of these things to remember. This, you know, like I was saying, fundamental geometry that is found everywhere. And I've come to it's going to be an existential review, this class. This is all there is to it, because without anybody to guide me, I'm just going to tell you where I'm at. And so I have come to really appreciate the universality of it, right? It's just become very comforting that every time I show up to draw with someone or solo, these shapes are consistent, right? There's this element of predictability where no matter how really chaotic or I'm trying to choose my words positively, deconstructing, however things look a little unstable, we'll choose that one in this human reality, right? Our civilization crumbling. I don't know what to put. I can look up in the stars, and I can't necessarily see a galactic spiral of a stars, but I can at least take comfort knowing that these patterns are everywhere. They are the same, and they are part of us, right? We've got this galactic cosmic scale, and then we've also got the quantum scale, which is beyond DNA, but the geometry scales both ends of the spectrum. I'm just going to pop out for a second, see if I can explain this. One of the things I worked with Nassim Haramein and the Resonance Science Academy. It's a great resource if you are interested in like a layman's perspective on physics. Basically, that's lofty to say that people could be able to articulate physics after studying his theory, but it's understandable, it's digestible. And I almost forgot where I was going with that, but now I remember. So one of the things in standard model physics, which is reductionist, empirical data, linear, rational, I think reductionist is the best way to summarize that. It feels like it's the science is the study of all the parts, and it fragments everything. It doesn't bring everything together. And early on, in the discipline, there was the cosmological scale and the quantum scale, right? And they couldn't find equations that bridged those two extremes, those two ends of the spectrum. And, Einstein came up with, E equals mc squared. But if you look into that, currently we are questioning that equation, right? We actually don't know what energy, mass, and time are. Right. So everything's being deconstructed, even fundamental physics equations that we took for granted. But the thing that bridges those extremes is space. There's space on all scales. And the thing that bridges space is geometry. So this disparate, seemingly disparate quantum and cosmological differences that you couldn't find equations for was called the vacuum catastrophe, meaning the vacuum of space. And so in essence, unified physics, looking at geometry and space as the fundamental principle that is in everything have bridged that vacuum catastrophe. So all sorts of cool stuff. I would really encourage you to look into just specifically Nassim Haramein and his work to be able to like explain physics to a 5-year-old, right? Because it helps us understand how to get to a sense of unity consciousness, right? We actually have building blocks, literally, in geometry. So I'll get back to the phi. The building blocks, meaning, the way that we understand and interpret our reality, and that our reality is structured through, genetic coding. And you can go as far as to look into, I'll come back out again, I'm talking more than I thought I would. When you go into genetics, when you look into the origins of human genetics, it gets really fascinating because Greg Braden has a series called Missing Links, and he talks about how our codons have been spliced, right? So studying the geometry is going to take you pretty far in terms of the human history and what we've been told is our past, and this whole evolutionary process. And I'm gonna pause with that, and 1 second. All right, so I want to welcome Roberta. We're shifting gears a little bit. We had a technical difficulty. I was completely not seeing her as being on the calls, but we made it. She made it, and so that will shift the drawing. I'll go at a little bit more of a reasonable pace. So I was just about to talk about the human history and looking into the influence and the nature of our DNA, right? And so Greg Braden, super awesome human. Missing Links, the series on Gaia. Have you seen that, Roberta? Have you watched that at all? Have you seen the episode on the genome, the codon number 2, and how it's very obviously spliced?
No.
No. All right. Go into I think it's the title has something to do with genetics, right? But it is literally the missing link, and that I won't go too far into this because we want to stay on the phi ratio, but the phi is our genetic structure, and so it can be manipulated. And once you get to being an advanced civilization, you have the ability to manipulate DNA. We do it, right? We do it genetic engineering modification. So geometry really gives you fundamental access to consciousness by reconstructing the genome. And it's really a fascinating docu-series because he goes into the implications, right? I'll stop, but it's really fascinating. I've spent some time in that, and then you start to question the whole human history and really where we come from and what we've been told. So geometry at the base of all of it, and just to prepare you, it really can unwind your whole worldview. So we'll go back into the screen share, and really, going into the reason I've gone into the phi in a new way recently is because I've been contemplating the concept of infinity, right? If the structure is everywhere, you remember it's got harmonic proportion, it's got a mathematic foundation of the Fibonacci sequence. It represents both the male and female aspects of our consciousness. It's this unifying shape, and it repeats infinitely, right? It spirals either infinitely out or infinitely in. And this is the Fibonacci sequence that adds on itself. It's the two integers that add or subtract on themselves to create the spiral. And this ratio of that's the ratio, sorry, this proportion, right? This harmonic proportion, this segment of B, which is 1, the vector is the measurement of 1. And then segment A is 1.618, right? So we've got a proportion that is 1 to 1.618. And that particular proportion is what creates that infinite spiral, right? It's that particular mathematic, right? That equation. And so when you look at that equation, when you break it down into a mathematical formula, to me, it starts to speak of a larger orchestration, right? We could look into advanced civilizations. We could look into the source of this math. And equations like this, you can see this slide of reading the Fibonacci sequence from the left to the right, adding the integers to continually get the same answers. You can read it from left to right. You can also read it from top to bottom on that right column, right? You're getting the equations that also result in different formula, right? Or different presentation. So left to right, up to down on the far right angle axis, right? The far right equations. And then you can also do it reading down from the first column and the middle column. And that, for me, this is the shape that's kind of invited contemplation of architecture and the larger design. And I was never in for math, but as I've gotten into the phi ratio in particular, I've really contemplated the direct relationship of how we interpret mathematics, and that it is the universal language, of math. So fascinating, endlessly fascinating, just as the shape. And this study of infinity has really invited the contemplation of us as infinite beings, right? We are not taught that. We are taught that we are these, I'm going to come out of this. We are taught that, the 3D reality is reality. The concept of energy. We looked at the dodecahedron, right? The element of ether, energy, space, prana, chi. Some cultures honored those elements, all 5 elements, but certainly here in the West, we were not exposed. For the majority of us were not exposed to the 5 elements and the energy of ether. What we had instead was standard model physics that could not find equations. All of their equations early on were ending in infinity, right? They were just getting these infinite numbers, and you can't have a societal structure based on infinite calculations. You have to have empirical data that is measurable and quantifiable and that you can base things on, right? And so they decided to sweep those equations under the rug and call it dark matter, right? Like, oh, we don't know what that is. We're just going to make it irrelevant, right? But that means that the equations that we use to explain our reality are insufficient, quite insufficient, like really mess with things insufficient, because we went off on certain directions based on the material world that are false, right? If you don't factor in the 99.99999% of space, you're off by a large margin. So getting back to studying the infinite nature of reality, it's reclaiming, it's bringing back quite a bit of our consciousness, and it's going to shift our entire paradigm. And the other example is junk DNA, right? Like, we have no idea what our DNA really does. So we just said, oh, it's not important, So really, the whole shift, the looking at the unifying principles changes your worldview big time, and the phi is at the foundation of that. So we're going to draw today, and we're going to look how space is dividing itself. And this thing is so cool because it repeats the pattern. It repeats the equation in the neatest way, and it kind of sneaks up on you, but we're gonna be drawing this structure. I can't really explain it without us drawing it. So this is part of the, you've got the curvature, and then you've also got the division that's on the diagonal bias, actually, that continually cuts the rectangle. It's fascinating. You'll see when we draw. And so all of these iterations are how we incorporate this ratio, right? It can show up in all of these different measurements, in the way that you find the ratio and the principle, right? And you see these everywhere in our bodies, right? This is that harmonic, this is the Fibonacci sequence, 2 and 3 is 5. And then you can continue it, for our entire body. You see that ratio of 1 to 1.618 built everywhere, the fingertips to the wrist, and then the elbow, and then also fingertips to the shoulder, as well as fingertips, all the way across. Sorry, fingertips, it would be the elbow, and then all the way across to the shoulders, the heads, the torso, and down to the feet. Just all sorts of essential geometry that is everywhere. And so when we see it externally, we resonate with it because it's got this harmony, right, that we see outside of ourselves. And because we have that fundamental harmony, iconic pieces of art that this proportion incorporates are, I don't want to say revered, but they're recognized for some reason. And the reason being, they're recognized as like iconic pieces of art and architecture because they incorporate that harmony, right? And so just if you back engineer a lot of our arts, right, a lot of the enduring pieces that represent entire phases of our civilization, you will find that ratio. And it's not as though the artist said, okay, let me incorporate that. This is like, it might be that, but it's part of the organic development of classic art, right? Pieces that that we recognize as important, but we don't quite know why. It's got this ratio in it. And then also the architecture. And I know that I went through a bit of these things in the first class, but it's just the reminder that this geometry is woven in so many aspects of our life. You wouldn't look at art pieces, you would not look at architecture and go, oh, that's the phi ratio. We just revere them and don't make that connection because the geometry is invisible, right? It's everywhere in our lives, but we do not factor it in at all, with the exception of being drawn to certain patterns and formations. And so there's the way of looking at it that's empowering and trying to see it everywhere, including marketing and how our consciousness is being influenced, we could say manipulated, in terms of utilizing the geometry to influence our subconscious and guiding us towards certain purchases and investments in brands that use that geometry, right? That is a very conscious process, is incorporating those harmonics. And then we drew the dodecahedron last week, and here's that 3D one, Roberta. I mean, it's not, in the 3D, you haven't drawn it, but you can find the relationship with the phi in there. And the phi is, I don't have it in this presentation, but the phi is perfectly connected to the pentagon and the pentagram and that 5-sided geometry. And then the dodecahedron is the pentagonal, 12 sides of five-fold geometry. And then also the icosahedron, you can find the phi in different elements of the Platonic solids, right? So you just start seeing the interrelationship and how every shape just incorporates itself. And then does that make sense? Every shape incorporates itself. Every shape incorporates this ratio, right? It's always going to come back to the phi. And part of my fascination with advanced civilizations led me to crop circles. And obviously it's a whole conversation, but this is one of the more genuinely obvious crop circles because it it was created in broad daylight, in England across from Stonehenge. 15,000 people saw it being made, and a lot of people had contact experiences in this formation where they started talking with advanced civilizations. So it's really a fascinating study. The geometry, as we were talking about with gene splicing, it takes you off planet. It takes you beyond human consciousness. You have to question what else is going on. And I just love the reminder. I mean, I had some images at the first, in the beginning of the presentation, but it's this beauty of how nature expresses itself as well, and I find it so satisfying to look around and remember. I started, Roberta, I started in the earlier part of the presentation talking about how comforting the geometry is, like when it shows up consistently over time. When our civilization is going completely chaotic, that it's always going to be the same. And that feels great. All of the shapes, right? The solids, Metatron's cube, the flower of life, super comforting to draw it repeatedly. So we're going to end on the cabbage, just saying, in our food, if you look into the geometry of Cheetos, it's not the same, looking into the harmonics of Whole Foods and the patterning. I want to get some more food pictures in there because it's fundamental to what we eat, right? The energy of what we eat, the healthy, unhealthy, and man, I feel so aware lately of food, and how our food is just it's toxic. It's like really bad business. So getting back into whole foods, and balanced foods that are feeding our balance, bringing us back into balance. But even those foods are influenced. So that's the phi ratio. We can get into drawing it. Roberta, do you have any reflections or contemplations about the phi or a relationship with it?
No, but I do recognize it when I see it because some of the plants that you show I have in my yard.
Yeah.
I enjoy cutting cabbage a lot for that reason, I
Hmm.
think.
Hmm.
I was wondering about the cauliflower and the broccoli because they have branches inside of them,
Yeah.
and what that looks like. You can't really cross cut that to really see what
Right.
the pattern is. But yeah, I eat a lot of whole vegetables and I've recognized the patterns that exist in food.
Yeah. And I did cut it short by one slide because there it is, right? The phi and the in the cauliflower and so many of our foods. And
Mm.
so, yeah, beautiful. We're naturally drawn to those. I can't eat brassicas, but that's okay.
Yeah, Brussels sprouts, tough.
Nope, nope, can't do it.
So
So,
fascinated as to how we'll draw this.
yeah, I used to draw this in a really shabby way, and I have to admit that. I would just use graph paper and build it square by square, which you can totally do, but it's very unsatisfying. It does not give you the understanding of the structure of the phi, right? So we're going to finally, actually, when I started going into that crop circle, I had this whole dual relationship where that was when I figured out how to draw it well. So, the relationship, who knows what's going on, really. We're just going to take it day by day, see how far we get, and try to board the ship if we see it. So, all right. Okay, should we jump in?
Yeah.
All right, here we go. So, let me get out of the screen share, or sorry, the slideshow. And then we're just going to get out of that because I just like getting out of that. We are going to go into the phi. All right. So we are starting with a 4-inch radius on our compass, which is going to give us an 8-inch diameter. So the 4 inches is going to be half of the circle. The width of the compass is the radius. And then let me tell you where to put it, right? Because we're not putting it in the center of the circle. We're going to find a specific location because we're going to build in a way where we need the space to do it. So you have the 5 inches, or sorry, 4 inches. Oh, and you're muted, so I can't hear you, but you good with the 4 inches on the compass? And I'm gonna tell you where to measure to on the page. We're not there yet. Okay, got that? Great. Okay, so what we're doing, and this honestly is an approximation, we're gonna get the general sense. You wanna measure in 5 inches, right, from the left margin. So 5 inches, making a mark at the top and bottom so that we can do a vertical line, right? 5 inches in, and go ahead and draw a kind of a light vertical line, right? So measuring 5 inches from the top, from the left margin on the top and the bottom. And then you can draw that vertical line. Oh, the vertical line, okay, so vertical line, and then from the top, you can measure down 5.5 inches, because that's the midpoint between 11 inches, which is the width of our paper on the vertical axis. And that will give you the center point for our circle, right? So 5 inches in, because we're going to build on the left side of the page, and then center of the page at 5.5. We got it? Or sorry, I might have said 5 inches on top. Okay, cool. So then that's going to be the point for your first circle. And draw everything nice and light, because I am sorry to say most of this will get erased as well, which is a very unsatisfying thing, but at least I've emotionally prepared you. So vertical line, and then you've got your 8-inch diameter circle on the left side, because we're going to build out to the right. I have tried to get used to everything getting erased, and it's every time it's just doesn't feel, it feels what's the word, counterintuitive, right? Because you've sort of invested in this the formation of the shape. So you can leave it. I'll try to remember right before the step of erasing, you can take a picture of it, and obviously you have the PDF where you can go back to it, but I'd like to take a picture just to sort of capture all of the work that's gone into it, and then we'll erase everything. All right, so we good? Okay, so we've got our circle here, and what we're going to do now is we're going to use the intersection here at the bottom, right? Your compass point, the compass is going to go here at that intersection, and then we're going to make a little mark on the right hand side. This technique of using a compass point and making a hashtag is really a fundamental step of a lot of geometry, so we'll just master that. And making a mark on the right, and really trying with some precision on this one, because it just pays off later in the geometry. Making a mark on the right, and then on the left side as well, right? So just doing the same step, and just double checking where that compass point is, right? And so we've got equal distribution here, and then we're going to do the same thing from the top, right? So we're going to put the compass point on that top intersection, and then swing it to the right and left, and get 2 more points. So you've got the 4 points just as I highlighted them there. You might want to highlight, because it does help with precision. All right, so we've got those 4 points. Now we're going to use those as our next compass points, right? So the compass is going to go, we'll start with the bottom right side. Compass is going to go there, and you're going to make a little hash mark right approximately where the horizontal axis would be, right? So you can, I say, make an inch wide or make it 2 inches wide until you get the sense of how to make a hash mark. Does that make sense? Compass goes on that point, and then you're going to draw a line that you could imagine goes over the horizon. Yeah. All right. Let me see. Make it any bigger. You're muted though, if you want to be. If you're just talking to yourself, that's fine.
No, yeah, we were muting so that your screen wouldn't go away.
Right.
So when I make this, I'm having trouble seeing today. When I
It's
make
really
this,
light.
it will be a curve, right?
Yeah, it'll be a curve like as if we were going to do a circle, but it's a
Okay.
curved line that's about an inch or 2 inches, and you'll get the hang of how long it should be as we go along.
Okay.
'Cause we're going to repeat that step a lot. Okay.
Yep.
Great idea if you want to go back on mute so that it just stays with my image for the drawing. So we've done that from the bottom, and then just similar as before, we're going to switch up to that top point, right? Compass is going to go on that top mark we made. And then you're going to make another hash mark, same step, only coming from the top. And that's going to give you another intersection point. You know, we're using the geometry, we're using the shapes to give us all of the coordinates, right? So then that's going to give you an X marks the spot. No. All right. Sometimes you have to make it longer than you'd think to find the line, to find the intersection. It might be our tendency is to go a little too short and then they don't actually intersect. So making a nice like 2-inch line, nice and light. It is hard to see on the diagram because I kept everything nice and light. So it's just a trick as you learn this step, right? So if you make the line long enough, you'll find the X marks the spot, and you can see it's pretty much on the horizontal axis, right? All right, so that's why we're building that. And you might want to darken in where the X is. Might want to darken in the cross point, is because it does help with precision. And then we've got 2 points now, so we have enough to draw a line. So we're going to use that point. We're going to line it up with the center, right? The center of the circle that gives us the 2 points, and you're going to draw a nice horizontal line there. You can end at the circle, right? You can bring the line all the way to the perimeter, or you can go past it because we're going to erase it. But I typically draw it like this. And now what we've done is we've simply used the circle to square it, right? We've divided the circle naturally with its own measurements, which is amazing. I mean, that in and of itself is its own cool phenomenon, right? All right. So it's nice. I've got you in my window. Normally, if I've got a bunch of people, I can't see everybody, but I can get a thumbs up from you and I know that we're there. Thumbs up. Okay. So now we're going to keep using the circle to square it. So it's that same step, right? Compass point is going to go on that intersection, on that horizontal intersection with the circle. Compass point goes there, and you're making another mark, right? Make it nice and big. It'll help find the intersection. And yes, it's as if you were going to draw a circle, but it's just in that segment. And then you drop the compass down and you do it below, right? We're getting this symmetry, right, of doing above and below. Same step, making that single mark at the bottom as well. Okay, so now I'm going to show you first. We're going to do that step from all 3 other intersections. So you're going to put the compass point. The next step is putting the compass point at the bottom. And then it's going to look like this. This is going to give you the first X marks the spot, that first intersection, because you're just repeating that step where the compass goes at that intersection point. You got it? And then that's going to look like this. It gives you 4 external intersection points. Right, so your compass point is going from each intersection, right? You've got the vertical bottom and you make an X on the right and the left, same step. Oh, you'll get it. Takes a little time, but when you get into advanced geometries and more mathematics, that technique of finding the coordinates by the X marks the spot, and then you're going to go up here. So this way, where do you want to be? You're going to go, compass is going to go up here as well, right? All 4 sides. You're going to do that same step where you swing it from the right to the left, and you'll start to see some of the X's, they form on each other. But you get that. All right. You're shaking your head. All right. I'll wait. Oh, hang on. Let me come out. Okay, wait.
I can't get the one close to the margin.
Okay, hang on. Oopsies. Oh, and this is so weird when there's only one other person I can't spotlight. So, okay, which one?
All right, so I've got the, I don't know, turn this thing around. This is a mirror
Okay.
image, right?
Yes,
I
yeah.
can't see an X. So is it an X over here? Yeah.
You got that one already. Now you want to go. Oh, you got it. Yeah, you've got all four. Wait, that one's a little low.
No, I don't have the right spot or something.
Okay, you want to go up to the top and make the mark on the right. That's all you need. You're doing it. You just one mark short. So this goes at the top intersection, and then you want to swing it over to. Yeah, you got it. You got all four.
I will in a sec, as soon as I put my glasses back on.
All right. So then I like to darken in those 4 points as well, right? Because it's again, it's going to help. Ultimately, down the road, when we build the spiral, the precision helps. And I love my perspective because I think this was before I really committed to finding the center and using the ruler, because you can see mine just has this little tilt to the right. It's just not perfectly vertical. So at least I can have a giggle at my process. So we've got all four. And again, we've used the circle to find a square. So are you happy with that? Hands are in the air. I can't tell. Okay. All right. Good for that. Now we're going to use those points to divide the circle in half, to bisect it. And we're cutting 4 segments into 8. And you want to stop within the circle, right? So it's just going to be the diagonal. Try to get it through the center. Take an extra minute to bisect directly through. You know, it can take, you got to do the tap to the right and the left, but it's worth it. There's a couple of geometries where absolute precision matters. Like we'll do the heptagon, and it can get down to the sharpness of your pencil that influences the shape. And I didn't know that until many years ago. I did a workshop, and half of the class had a sharpened pencil and half did not, and half got the shape and half didn't, and I couldn't figure out why. At least some got it right. We're going to do it on the other side. But I really learned it was invaluable that it can come down to that, right? So do we have both of them on both sides? You all set? Okay, great. So again, I think it is so cool that we've used the coordinates of the circle to get the squares, right? So we've got the external square, and then we're going to connect those points, and we're going to make an internal cube. Okay. So each of the points getting us to the square that is going to be, this is now the segment of 1.618, right? So we've got that segment, and we're going to build the 1. We're going to build the golden rectangle, and it's called golden because it is the highest iteration. You know, gold is sort of our highest standard in our society. And so golden meaning perfection, right? The golden ratio, the Fibonacci sequence, and the golden spiral being that perfect harmonic pattern that repeats. My friends just had a baby, right? And just, oh my God, I got to see it when it was 2 days old. And just to contemplate, you know, humans are fractals, right? We are self-repeating patterns. And all of us in our genetic reproduction, it's quite fascinating. All right, we got that. Got the cube. Okay. So then in order to get that ratio, that golden ratio, and we're not drawing a line, we're just taking the measurement. Again, we're taking the measurement from the shape, and you're going to use the measurement from the bottom vertical. We're not drawing the line, the bottom vertical intersection, horizontal and vertical intersection, and you're going to measure up to the top corner, which is going to hopefully give us the measurement of 6¼ inches. It approximately, right? It's close enough to count, even though I've been saying precision the whole way. So then what we're going to do is use 6¼ and we're going to start the measurement. This is the important part. Start the measurement from the midway point of the square, and you're just going to draw a line So it's going to look like this. It's going to extend 6¼ inches out to the right. We're building to the right to build the phi. So we are extending itself by with the relationship between 1 and 1.618. So you're going to do that on the bottom. You're going to repeat that step on the top, starting the measurement from the center point, extending over to the right. So creating that structure from cube. Oh, excuse me. And then we're just going to connect those 2 points to give ourselves the rectangle on the right-hand side. So it's going to look like this. All right, great. All right, this is the place you want to take a picture because we're going to erase almost everything now, which is a bummer. So do you want to pause and take a picture, or are you fine because you'll have it on the, all right, yeah, all right. It's just in some of the classes, everybody's like, wait, this is so beautiful. And then to get to the next step, which requires, it's just nice for posterity to remember everything that you did to get there. I like that as well. All right. So we've got this. Now we're going to erase everything except the rectangle and the square. Get this perfect ratio. This is the 1 to 1.618. And we've gotten that solely from the circle, right? So there's this beautiful, that's part of the harmonic relationship, is it's all within itself. This is the only geometry where you do not have to bring in an integer. There is no third party here. This is 2 integers. It's a unique equation in that regard. It's the only one. I'm so on the metaphysical side of things, and I, like most of us, well, that's not true. Many of us, I had serious math trauma. In fact, geometry in particular was where I really shut down. I had a terrible geometry teacher, Mrs. Fitzsimmons. so I was done, and then was lost for my 20s and 30s, and then started finding my way. Well, in my 30s, I found, in my 40s, I found the geometry, and this has been reparative, right? I have found an excitement about math that I never had. I had a fear of it and a lack of confidence. And when it's not just numbers and an equation, when it's anchored in the structure, I can conceive it. I can conceptualize it. And I wish that we drew that way. We learned that way in school. All right, we got the golden rectangle there. Okay, now what you're gonna, yay, nicely done. What we're gonna do is consistently divide this thing again and again with the pattern. All right, this pattern, we are going to divide the shape on the diagonal. We're gonna bisect the shape from the right top corner to the left bottom corner. And we're just gonna keep doing that the whole time. It's gonna bisect the rectangle on the diagonal. That's it. That's all you do to get this pattern. It's amazing. It's amazingly simple and extraordinarily complex at the same time, which is the paradox and irony of our existence, right? I'm just in an existential struggle lately. I'm just like, God, the density of this place, there's so much that I cannot reconcile within my psyche. All right, we got that. So it's gonna we got this, right? And now here's a really cool thing. We've divided it on that bias. So right here is the segment of 1, and down here is 1.618, right? We've just divided that in and of itself. So we're going to use that intersection. Sorry, we got one more step. Now we're going to measure from the top mid vertical line up here down to the bottom right corner. Oh, yeah. So, all right, we got that. Okay. So we've just repeated the pattern, right? We've divided the whole rectangle in sort of half, and now we've divided the rectangle on the side in half as well. So this intersection here, the lower one, that's what we're going to use right now. So we're going to bring the compass back into it, and you're going to close the compass to the measurements of the bottom vertical intersection with that intersection that we just created, which is the 1.618. And actually, yeah, great. Okay, so you've got this. We got this? Thumbs up? Okay, I won't go until we've got thumbs up. All right, thumbs up. So you've got this measurement. So keep the compass in that orientation. Keep it right there with the pencil, with the compass pointing to the right. And we're literally just going to slide it over on the parallel to make a mark here on the opposite side, right? So it's gonna mirror the dimensions of the intersection on that vertical line. Yeah, just sliding the compass right over, not changing the width at all to find that, to make that little hash mark on the outer vertical line. All right, got that. And then that gives us our coordinates for that horizontal line, right? So drawing that line from that left hand intersection across to the mark that you just made. Okay. Looking good? All right, so we've just divided that rectangle into the ratio. The top one is 1, the bottom is 1.618. We've recreated that ratio. Isn't that cool? All right, so we got that. Now we're going to do the same thing again. All right, so we're using this intersection point that we just created, right? So your compass is going to open to the width of that intersection we just made and the outer vertical intersection over here, the horizontal and vertical that we just created. Every time we're giving ourselves the steps. And on this side of the country, it's 12-12, which is so fun. Yeah. All right, got that. Okay. And we're going to do that same step where you're going to just pull the compass straight up on the vertical axis, and you're going to make a mark on the outer horizontal border of the rectangle. Okay, you got that? And then that gives us the 2 coordinates to make that vertical line, right? So we've divided that rectangle into the segment of 1 and the cube of 1.618. So we've got the golden rectangle here. You can see how it's repeating. All right, got that? Okay, and then we're going to do the same step, right? What we've got is this measurement here. We're going to close the compass to this measurement because we're just getting smaller and smaller, and we're using the same intersection proportionately the same intersection that we create every time. All right. And now I did a little thing here. I flipped the compass. I used it on the top to show us, I just happened to, in error, use the compass this way. I think it's easier to photograph. But you want to flip, you're going to drag the compass over to the left, and you're going to make a mark. She's nodding her head like she gets the pattern. She gets the fact that it's the same step and it repeats in this beautiful way. So then you're drawing that horizontal line right there and creating another golden rectangle from the previous golden rectangle. Looking good? All right, same step. Using this intersection, we're going to close the compass there to that width using the proportion of the 1.618. Right. And then you're going to do that same thing where you're going to make a mark right across from it on the, this is going to be on the horizontal line, right? You're using the vertical points to make a vertical line. Here we've got the making the mark on the bottom on that mid horizontal. And then that gives you the 2 coordinates for a vertical line, which looks like this. We're just getting smaller and smaller with the same step, right? So you've got that rectangle, and then we've got another one, and this gets kind of small. If you need to eyeball in here, feel free. But closing the compass again to this segment that we just created. And I think I always encourage people to stop here because beyond this, it gets, harder, but keep going if you want. And past this, I do eyeball. So you're going to pull that compass over with that width. It looks like you might have that already, making the mark on the opposite side. And then that's going to give you a horizontal line as we connect that. All right, great. And then this last one, this is where it gets a little small. Here's our horizontal line that we just made, and then closing it again to that tiny width on the horizontal axis. And then drawing it, making that mark above, and then getting, dividing that rectangle into the golden ratio. You get one last cube and one last rectangle, but that gets really finite, and I do, we stop there because otherwise we're cycling into negative numbers. All right, so to pop out, excuse me, how's it going? You got it? You looked fairly confident. We've built the Fibonacci and the structure piece, right? No rush, it's okay. Put it back up if you'd like. What day is it? Is it Sunday? Excellent. Oh, yeah, it gets tricky when it gets smaller, so.
Yeah, I need to put a finer point on this pencil. It's seen too many circles.
Yeah. I tend to not want to sharpen it because I don't want to take it out of the compass and miss the positioning, but it does help. It does. And then I have a crop circle drawing class. I'll show you the crop circle.
Okay.
But I've started using stencils, right, and templates for the smaller circles, and I feel like it's a little bit of a cheat somehow, but it really helps with tiny circles. Oh my goodness, what's happening? You got it?
I don't know. You tell me.
I bet you do. Hold it up a little bit. Yeah, of course you do. There you go.
Okay.
Brilliant. Okay. All right. So now we're going to go into the spiral, and if you're frustrated with any inconsistencies in the square, I'm just going to tell you, this is like a complete ballpark, right? You're going to be moving the compass around to see if the spiral is matching up. So this is a ballpark. All right. And it's the first one. It's human imperfection unless you're doing graphic design, as with all of the other ones. So here we go. All right, we've got this perfection. Now what we're going to do is compass is going to open, and I think it'll open. What compass do you have? Let me see. All right. Yeah, great. It'll open. So compass points here at the center intersection of the central vertical and horizontal. Open it to touching the far right corner. And what you want to do is you want to tap around, you want to tap the pencil to that top right corner, swing it down. Don't make the line yet. Swing it down and see if you're matching up with the bottom vertical. Yeah, that intersection. Because what we want to prioritize is the spiral. What you want to have happen are the tips touching, because then it looks like a continuous spiral. So getting as close to the bottom intersection as you can, and you can move the compass point around in order to get that. That's part of the fudging. That's part of the process to finding, the curvature, matching that part of the shape. perfectly, quote unquote, symmetrically. All right. Oh, all right. Down. Take your time. I can always talk and fill the space with so many facts. All right. Looks like I can't tell you had the lift, so that might be it. All right, we got that. Okay, now we're just gonna keep doing that pattern, right? Same as before. We're gonna use the top intersection point of the cube, right? On this shape, it's the top right. Then we're gonna come down to this cube here, and we're gonna use the inner point of this one as well. Right, so a compass point is gonna go here, you're gonna close, just like with the rectangle, you're gonna close the width of the compass to that measurement. And you wanna prioritize lining up with the spiral down there, right? Make that be where your pencil point goes, then put the compass down, then give it an arc up and to the right. So we are currently going counterclockwise to build the spiral, which is an interesting thing. Oh, there's the frustrated hand wave. Okay. I think you make that gesture right before you erase something. All right. Just got to find the eraser. All right. Oh, sharpening the pencil. Yeah. I always take it out to sharpen it. It's just going to be more effective. I am going to run into a bio break while you are erasing, and then you're making the second arc, right? Are you still on that? Okay. I'll be right back. Okay. All right. Oh, that was very helpful. All righty. Pencil sharpens. We got that one. Yep. Okay. Then we're going to move up to this inner square point, the inner square point, right? Compass point is going to go there, and you're going to swing up and to the left, right? So compass at that inner intersection of the cube, and then it's going to look like that. Sorry, I put the compass in the wrong direction, but you're going to put your compass at this point, this intersection, and then you're going to swing up and to the left. So it looks like that. Again, like trying to make the arc the place where it lines up. Lots of fudging, Human imperfection, perfectly imperfect. All of the shapes usually elicits the critical voice, right? It's not right. So we got that one, that top one. Nope. All right. Yeah. What's happening? Do you want to come off mute and tell me, or is it the instruments?
All right. So I'm at this size, which
Yeah.
is the line going up from the
Uh-huh.
larger, and I put the point at the lower point. I don't come
Mhm.
anywhere near that.
Let me see.
Oh God, I can't do things backwards.
No, you want the compass at the, yeah, open that up. Open that
Okay.
up to touch the
Okay.
vertical.
All right.
Okay, you got it. The right origin, but too small. Because I skipped the step, so my apologies.
Okay.
Yeah,
Okay. Yeah.
you want this as the points, and you want to open up on the horizontal until the right vertical.
Okay. It matched. Excellent.
Okay, great. And then swinging it up. So sorry that I skipped to the next step, but you've got that arc going up, and then you want to close the compass to this width, again, um, measuring the 1.618 segments. That's giving us the arc down to the bottom, which looks like this. And honestly, building it this way is, for me, I really see the process of how it is a self-repeating pattern, breaking down rectangle to rectangle, and then how the arc requires the measurement of 1.618 versus the 1. So I find it very satisfying. We've got the inner square, the inner point of the cube. And then the spiral is also the guide, right, as to where, the width of the compass. All right.
I'm embracing my imperfection.
You have to. It's the only way to do the geometry class. All of the drawings, all of them. All right. So you got that arc. Okay. Sufficient. So we've got that one, and then we're going to come down. Okay, we're going to come down, and the compass point is going to go at the inside there. And you kind of place the compass point based on the spiral, right? The spiral is kind of showing us the way for the next division of space. I should have paused for our bio break. That's okay. And then once you've closed the compass to that width of 1.618, you're going to make another arc coming down from the top left to the bottom right corner. Yep, we're good. Perfectly imperfect. All right. And then you can see, to continue the spiral, the compass point closes again, and the intersection, the inner top left intersection of the cube, that second to last cube that we've made. And you can stop there because you can see the compass gets so small. Or you can, I tend to eyeball the last one, right? So this one I can still pull off the compass, but for that smaller segment, I give it a good handmade arc, right? Non-technical arc. So that gives you that cube, and then again you can just eyeball the spiral going up to finish it. But you can see infinitely on, right? Graphic design is going to be more precise than we can, but you should have, or you're going for this. All right. Somewhat satisfied? Okay. Let's see when you're ready. All right. Ah, brilliant. Same shape every time. So you're gonna come off mute. How's it? What do you think?
I think it requires a better compass.
Uh-huh. Like, right, that's the precision piece, right?
Yeah, yeah.
I just love that
Other than
compass,
that, it's wonderful.
right? So
Yeah,
solid, so solid, you know? Yeah.
yes,
It's harmonic. Yeah.
it is. Yeah.
And it's even though the ratio is 1 to 1.618, there's a symmetry in it. There's a
Mm-hmm.
symmetry in the repeating pattern.
Mm.
Mm, yeah. I've really, really gotten into this one in the last 2 years because it's just the study of infinity and that there's a structure for infinity and that bridges all of our disciplines that, were false to begin with. This is a good place to start.
Mm.
Yeah.
Mm-hmm.
Perfectly imperfect.
Oh yeah, I'm not worried about that part. I'm seeing if it's talking to me.
Hmm. Yeah. Are you getting things, or are you just making the space for it, or which?
Yeah. I don't know. I was drawn to use it in my logo as I showed you, and I mean those weren't anywhere near perfect fives, but the uh, the method to which you draw it, everything with the circles is a oneness to it, right?
Mhm.
So then you've got all these squares which feel confining in a way
Mm-hmm.
in comparison to a circle. In a circle, you can go, well, you can do it you can do it well, anyway, it just feels different. So
Yeah.
that's the that's the interesting part of it, really. And then you've got a couple of triangles going on. Yeah. All
Mm-hmm.
right.
Well, and it's based in the division of the circle, right? So
Mm-hmm.
that energy is
Mm-hmm.
presence,
Yeah.
right?
Sure.
Invisibly. But
Right.
yeah.
Right. Right. Thank you.
Very cool. Thank you. I love hearing how it's speaking to you. Um, okay. So we've got the phi, yeah?
Yeah, it's also open-ended in a way.
Absolutely.
Yeah.
Mhm.
Like there's possibility and potential.
Infinite.
Right.
Yeah.
Yeah.
Yeah. Very cool. Very
Yeah.
cool. And I love the classes because just everybody's perspective and, whatever they're hearing is so unique and reflective of their personality. So somewhere that's a reflection of your interpretation, where there's just,
Mm-hmm.
open-ended and so much
Mm-hmm.
potential.
Yep.
Yep. All right. So I like to sneak in the vector equilibrium for this class, and I'll do a little review of it, and then we'll draw. And it's really amazing how you can get it done pretty quickly. It's super cool shape. But I'll tell you, did we talk about the vector equilibrium a little bit? I don't
I'm
think
not
so.
remembering. Yeah.
All right. So do you want to put yourself on mute for a second while I do this? All right. So we got the phi. Oops, that's vector. All right. So vector equilibrium. Uh, it's called the vector equilibrium. Uniquely, this is the only shape in like all of everywhere that the lines, the vectors, are equal, right? They're equal length, and so it creates this equilibrium. It has the ability to oscillate and generate its own energy and maintain it like for a very, very long time, which creates essentially this point of singularity, which all of the lines are equal. I mean, that is an extraordinary thing that I can't quite, go into, but I want to tip you off to this shape because it's essentially the shape of free energy. Did I just say that twice? So that point in the center is, you can interpret it as a point of singularity, right? A black hole, a proton, an infinite source. And it's also called the cube octahedron because it's a cube and an octahedron mashed together. to make this perfect shape. And Buckminster Fuller, coined it, the vector equilibrium, and based a ton of his math and architecture on it. And the way you get it is, I'm going to mute the video. Can you still hear me if it's muted? Okay. So this is how you get the vector out of the star tetrahedron, right? The flower of life makes the star tetrahedron. You pull the tetrahedrons off and you have this perfect shape that is not disturbed by removing any of the rest of the geometry, right? It's really fascinating. And I will show that again. Here's the star tetrahedron. This is the large star out of the flower, Metatron's cube. You take those tetrahedrons off and you have this perfect geometry that is self-sustaining. So once again, in the flower of life, out of the basic seed of life, you've got this incredible geometry that could potentially change our entire worldview, our entire civilization. Because if you have the geometry of free energy, you can harness it, right? You can, this is Tesla technology, this is scalar technology. It all incorporates the geometry of this structure, right? And so this is a source, an infinite source of energy, of just space, right? This is geometry of space, essentially. And so that is an external source of infinite energy, and it's also an internal source of infinite energy, right? This is the still point that we seek in meditation, where that infinite potential, just like you were speaking to, is possible, right? So using this geometry to find that point of singularity, that moves us from, anytime you're talking about infinite capacity, especially when we're in reference to energy and an energy source, you have the ability to completely change our civilization. We would move from this illusion of scarcity, limited resources, fighting each other, world destruction and war, into a consciousness of unity, abundance, and interconnectivity. So this is really the shape of massive transformation, which is part of why this geometry, the dodecahedron, right? These are top secret. It's why Tesla was killed. It's why all of this information has been kept from us. It's very available. These technologies are very available on a government level, but we're just, starting to get back to them because they could upend the controllers, right? That's dynamic in the agenda that we have right now playing out. So vector equilibrium, cube octahedron, we're going to draw it to hopefully represent the three planes, right? You've got the two diagonal planes. On the green, it goes all the way through. You've got the blue on the other diagonal. You can see it goes all the way through. And then you've got the red on the horizontal. And I like this image because it gives us the idea of the dimensionality of this and takes us into the singularity. And there's that image. And then you can also isolate the tetrahedrons and the cubes, right? And look at how it would look in another three-dimensional relationship, right? So it's just super cool. I want to go back to this slide. And here's the relationship, right? You've got the 64 stars, you've got the flower of life, and then you've got the bones, which is the 64 star tetrahedron, which we're going to draw in the next couple classes, which I love. And then the dodecahedron, nope, that's not right. The vector equilibrium, there's two of them. Just like with Metatron's cube, you've got the outer one and you've got the inner one. It fractalizes, right? So here's the outer version and the inner version. And then another way of showing that is this, right? So the red and the orange are the tetrahedrons, and then you've got the yellow vector equilibrium on the outside, and you can't see the one on the inside, but it's in there, right? So yeah, this is the whole relationship of how you get to it, flower, seed, all of that. And then that's it, right? I mean, you can tell there is an infinite study on this shape. It's fascinating. And it really is the key to transformation for our consciousness. So drawing it can also create some shifts. This is the shape where in one of my college courses years ago, we do the introductions. Why are you here? What are you going for? And this woman said, I am, someone told me I could talk to my dead husband through the geometry. And I was, okay. And then by the third class, we got to this shape. She went home and drew it, and she came back and she's like, I heard him. I started talking with him. And it had been a really traumatic death. And this like accessed incredible amounts of healing, transformation, and she packed up her life and went to study plant medicines in South America. It was really like, never underestimate the power of the geometry. And it's so fun and easy to draw. So we're just gonna jump right into it. You ready? Do you got any questions? Does it make sense?
Yeah,
Yeah.
it makes, I love it.
Okay. How are you muted? Because, oh, mute. I have muted. Okay, there you go. It was me.
I have to do a quick cap break. Hang on.
Yeah.
Okay. If he doesn't stop meowing, it's gonna make me mad.
Okay.
Come on. Let's go. All right. It's okay. It's not dinner time. And no, it is not dinner time. Okay.
Yeah, my boy also, but all right. You ready? Oh, you're muted. Okay, but that's fine. So we're doing a seed, so same orientation, and we're gonna do a 2-inch. You can do 2-inch, you can do 2.5. 2.5 stays on the paper. So on the, yeah, let's do 2.5. And doing the seed as lightly as possible, because that helps you erase it after you're finished. And measuring on the vertical axis, right? 5.5 in will give you the center point, because we don't want to go off the paper as much as we can. However, we will still get the shape even if we do, which is one of the cool things of the geometries. Yep. Okay. And also trying for precision, always trying it, but then the partner is the satisfaction with imprecision, as we've been talking about. That's one of the biggest reprogramming access points, right? Is we're not going to get rid of that voice at all. It is so deeply ingrained in program. But what we can do is find the opposite positive. Or not opposite, even we can find a positive to balance that out. How are we doing? We got a seed of life there? All right, so you're muted. So if it's something vital, I can't hear you. Otherwise, you're just in your talking to yourself process.
I have a 5-inch circle, not a 2.5-inch circle.
Right, you want a 5-inch circle. 2.5 is the radius, 5.5. 5 is the diameter. You got it. Yep, exactly. You've got it. 2.5 inch on your 2.5 inches wide on your compass is the radius, and then that'll give you a 5-inch circle. You got it.
But I'm going off the paper.
Are you on the top and the bottom? That's all right. Don't worry about it.
Okay. All right.
I mean, it'd be fun to stay on the page, no doubt. But it's also okay.
Okay. Great.
Okay. All right. So if you could go ahead and mute, because it is a crazy echo. All right. So what we're going to do is we're going to be using these points. I'm going to show you the points first. And this is why the top of the circle can go off the page. So we're using the divots, right? We're going to be bisecting the shape with the divots. So you're going to make, and it does help to put a little point just to orient. Oh, let me tell you, wait, a couple colors. We want 4 colors. Do you have color pencils near you? Cool. All right. So choosing your 4 colors first, and then we're going to make those points with one of the colors. Oh, wait, what are you doing? Are you drawing a line? Don't draw a line yet. Okay. Okay, still some circle. But tell me if you're not ready. My goodness. Big seed. Oh, yeah, perfect. Are the divots still on the page? Yeah, they look like they are. That's fine. That's all you need. Yeah. All right, so four different colors. I always say, sorry if you've done this already, I always say yellow. Oh wait, which ones did you choose? Great, perfect. Yeah, contrasting colors and not a yellow. Okay, so picking your first color, all right, we're gonna place marks at the two outer divots, right, these 2 points. And then also we're gonna put 2 at the inner points of the petals, right? So you're gonna get, we're gonna actually make a terminated crystal. So you got these points, 2 outer divots, and then parallel points of the start of the petals. Okay, okay. Now we're gonna connect those points with that same color, double terminated crystal, right? So diagonal on the top from the divot over to the petal top. Same thing on the other side. I've got allergies, it's fall. I wouldn't have thought there were allergies in the desert, but there are. There's allergies everywhere. It's not bad, but it's noticeable because it's October. How that happened. I've been talking in a lot of my calls about the strangeness of time and how it's just getting so wonky. And yeah, one day feels like a week. Okay, we got that? Perfect. Okay, perfect. So then we're going to choose the second color. All right. And we're going to make those dots again, only on the right axis, right? So tip of the divot on the upper part. And this is why the geometry can go off the page, because we only need the divots. So top, bottom, and then again, the petal points, right? And you've already got one of those used up, but you're going to orient that way on the other axis. So still available. You know, again, just using the shape and its coordinates, right? We're not adding anything. All right, head scratching. Don't worry. We're not going anywhere till I get the thumbs up. I'll grab my crop circle while you're doing that. All right. Got it? I bet you do. You just, okay, you got it. Okay. So it's going to look like this. So did you, yeah, so you want to connect them same color. And then again, it's the same shape. It's the double terminated crystal. Right, we're just highlighting what's already in the shape. And at the beginning of the course, there is no way to understand that the seed of life literally gives us everything we need for all of the shapes, all of them, 64s, the vectors, you know, the flower, like it's the germ of life for a reason, right? 7 circles. How does that happen? That is an advanced civilization that has shown the way. All right, so we got that, axis. Now we're going to do the horizontal. You can see that's the only one left. So third color, right? And using the points on the horizontal axis, those 2 divots on either side, using that color to darken them in to help us get there. Yeah. Right. And we're going to make that same shape. It's just going to be on the horizontal. You got the hang of it there. Right. And so that gives us, you know, we've got the 3 planes, and this is one of those shapes where you can play with your perceptual capacity, right? Seeing which plane you see, but it also, fascinatingly enough, gives us a star tetrahedron, gives us 2 star tetrahedrons. So our Merkaba, our light body, is also woven into this, right? So much in this shape. grab that too. All right. Okay, groovy. Now, fourth color, we're going to draw the hexagonal boundary, right? So you're going to connect the outer points, connecting, making a nice big hexagon, connecting the divots and also connecting the points of the crystals. And it is fun over time. Your brain starts to be able to see the different dimensions. And like I can definitely see the cubes, the inner pull, like that orange one we saw. I can see the outer going into the inner easier. And playing with this dimensional shape, like we're going to get to the tetrahedron. Okay, she's stepping back to look. We got that. All right. Now we're going to draw inside bisecting lines. Right, so we're going to cut the shape in half on the left axis and right axis. So each of the shapes, the yellow, the blue, and the red, we're going to cut them in half with that same color. Okay, so bisecting using the tips of the crystals, right, to cut the shape in half 3 different times. All right. Mm-hmm. Yeah.
What color am I using?
Same color
As the
hexagon that we just did. Same color, because we're gonna give, and if you draw this one in like with no color, it looks just as cool that way as well. But I like to do it this way to sort of show the different axes. Got 1, 2, 3. And then the horizontal. Yep. All right. Now I'm going to show you what I did on the next step because I complicated it by erasing the seed in the back, right? So what we're going to do is the inner petals, right? The inner petals of the seed, we're going to do another bisect. We're going to cut those in half so that you've got this inner tetrahedron, right? We're going to use the tips of the petals, the tips of the tetrahedron, and we're going to bisect those. We're going to cut them in half, right? So it's going to look like this with the same color. I just erased the seed so it's confusing, but you can see the lines come down through the tips of the tetrahedron. Same thing, the lines are bisecting those petals. And I leave it open. I don't color in the planes because it's hard to, you're bisecting the colors in the 2D, so it doesn't work as well, but it does work. All right. Looks like you got it. What class is this 4 or this is 4? This is class 4, right? Okay, we got that. So there you go. Let's see it. Yeah. Ah, brilliance. Look at that. What do you think? Did you do that in pen? You want to unmute yourself?
no, just
Oh,
really good
okay.
pencils.
All right. So what do you think?
I like it.
Mm-hmm.
I like it a lot.
Yeah, it's got some dimensionality. This one gets fun. This one gets really fun to stare at for a while. I mean, they
Good.
all are. But this has a different feeling to the phi. Very different feeling, right?
Oh yeah.
Yeah. Yeah.
Definitely. I like anything with depth because I'm a very deep person.
Mm-hmm.
And the phi is too simple, but mind expanding versus when I can jump inside of something,
Mm-hmm.
that's pretty cool because I jump inside of my own thoughts, patterns, and subconscious and everything else on
Yeah.
a continual basis to understand who's in charge.
I don't know. Is anybody in charge? Yeah. You know.
Yeah, I have several, 21 to
Yeah.
be exact.
Oh,
Okay.
all right. All right. Fabulous. Um, Yeah, well, there's 22 dimensions, so that, well, there's 22 in from a certain perspective, so that's kind of fun.
Yeah, 21 aspects of my ego
Ah, yeah.
stood up and announced themselves. I wrote a book, and then the higher self was all just trying to get them to all see their part in the program, so that we could all accept the higher self and work together. Because this destroying the ego thing never set right with me. We need
Mhm.
it in order to exist.
Yeah.
So cooperation was the word that was necessary, and we're
Mhm.
getting there. We're getting there.
Oh, it's the good work, right?
Yep.
Yeah. Yay. So, all right. Any other thoughts before we wrap up? Like on the total, on the whole?
Um, do you do all right? So, as I said, I had been drawn to you, one, for your enthusiasm, two, for the whole transformational piece of the work.
Hmm.
Is there something you can do in addition to just drawing that helps you feel the transformational part, I guess?
Hmm. Uh, Honestly, it mostly is the drawing.
Okay.
And what I will say is the drawing of these shapes, the one I work with the most where I do actually experience something is this one.
Yeah.
So the Shri is like, the geometry took me to this, and
Mm-hmm.
I've drawn over 30 of them in my house. I repeatedly draw it, but this one, working with it, it's just like, just this portal opens up. Um, and I've, it helps, um, occupy my mind in a way that I can, go up into another realm and connect with the other aspects of myself. So that's the one. The others I love, and they bring me into alignment, which then opens up the channels. But drawing those activates me, and just sitting with this one activates
Mm-hmm.
me. So
Okay.
yeah, we
Well,
also can learn how to draw that one too. It's very doable. So, I mean, come on, like, look at that. I mean, it's, once you've got this foundation, it's, the coordinates, it's the same. They're right in there, but it is definitely more complex.
I do have that in beautiful color in my office in a massive poster
Mhm.
size. I believe when I first started studying, do you work from the outside in, right?
Yeah. Yeah.
Okay.
Yeah. And this one, like, the vector has its own significance, right? The Shri, like, literally like, I don't want to say every, but the majority of the Hindu pantheon is represented here. Every single aspect of human consciousness, and how you transcend from the mundane into the metaphysical, or there's a word, sublime, but the higher states of consciousness. It's
Mm-hmm.
all in there. Every triangle represents something. So, I mean, this is technology. All of them are technology, right? And so, developing, um, and man, it takes discipline. That's the place that oh my God. Oh, yeah. Lifetime practice, right? It's just, so I guess the answer is like discipline and a certain geometry, and really meditation though. But I have liked the drawing because it makes the meditation piece easier. It gives my left brain monkey mind a way to focus and be quiet. And then,
Mm-hmm.
you have to pivot. You have to practice long enough where the shape is more routine. So you don't have to think about the coordinates, here's where the next line goes. And you do it enough that then you
Okay.
can actually consciously open up the other sides. So
Okay.
the other thing though, I will say, and I will add this piece as my like check-in of, my drawing, because I decided this fall I was going to draw every time with everyone between the classes. But what that means for me is drawing crop circles. So another answer would be that the geometry took me to the crop circle, which then is really activating, because that's advanced technology, the genuine ones. So I'm teaching a 4-week drawing crop circle class, because so many of the peeps that I've been teaching with, that we've been traveling with over the years, they also joined on the crop circle bandwagon. And so the next iteration of studying those is drawing them in as sort of a back engineer, but you're working with it in the consciousness. So this one is like the most crop circle-y one that I've done yet, but it's
Mm,
super, it's, I
mm,
don't, we don't get to know what it means, but
mm,
through this one, we recreated it with a bunch of people last night. And so it turned into this. And, you know, for whatever reason, and it's very, very much like Richard Dreyfuss in Close Encounters with the Third Kind, right? It's like it's activating those parts of us that I think you're speaking to. We're preoccupied here, but information is 90% of that junk DNA, like aspects of our consciousness. The Arcturians, who I work with quite a lot, they talk about how sacred geometry and crop circles are the way to activate your telepathic powers, right? Like this stuff is designed to turn us on. And
mm,
so, you know, drawing the geometry, yes, that led me to the Shri. It led me off planet. So, then you're working with advanced civilizations that really know how to turn your, which is also your higher self, your future self. So it's all, don't want to externalize any of that activation technology. So
mm.
that would be my answer.
Excellent answer.
Oh gosh, it's at least not dull. I'll say that. So and it's just such a treat to sit with you, Roberta. I'm so glad you show up. I'm so glad this does it for you as well.
Okay,
And it's a real honor. So
likewise.
yeah.
The next time, what I'll do is I will click in because I usually click in a few minutes before 2,
Oh
and
yeah.
2 o'clock for me. And if I don't see you answering pretty quickly, then I'll jump out and I'll jump back in because that's the only
Okay.
way I got to see you today. So,
Okay.
okay.
So and also so I'll come on a little early and I mean, it's fine because it's you and me, so the time's a little bit
Hmm.
shorter.
Hmm.
I'll also send you the link ahead of time, so we'll just make sure that that doesn't happen again.
Yeah, I think it was the same link. Obviously, I got to you. So when I
Yeah,
asked you 2 times ago if we're using the
yeah.
same link and you sent it to me, that's the same one I used today. And it does come up with, it looks like 5G, but I don't think that's, it's for your friend's Zoom account, apparently. Um,
Hmm.
uh,
Okay.
and it says that the host is already here and we'll let them know to let you in.
Yeah,
And
and I
the
never
circle
see
goes
it.
round and
Okay,
round.
so jump on, jump off, and then
Okay.
hopefully we'll get it.
All right.
And
All
I
right.
will keep an eye on my email as well.
Okay.
All
Very
right.
good. Yep.
Wonderful.